GATE 2018 Civil Engineering Set 1 Question 11. The width of a square footing and the diameter of a circular footing are equal. If both the footings are placed on the surface of sandy soil, the ratio of the ultimate bearing capacity of the circular footing to that of the square footing will be. The four options given are 4 by 3, 1, 3 by 4 and 2 by 3. The relevant NPTEL reference has been mentioned. So, if we are given a strip footing which is of width B located at a depth of df below the ground level, the soil has a cohesion of C. The ultimate bearing capacity as per Terzaghis bearing capacity theory is given as the sum of C and C plus gamma df nq plus 0.5 times of gamma b n gamma. Here nc, nq and n gamma are bearing capacity factors. C is the cohesion of soil, df is the depth of the footing and gamma is the density of soil, b is the width. So this component comes from the shear strength of soil. The second component is a result of the surcharge, and the third component comes from the self weight of soil. So this is the case for a strip footing where the length by width is much larger than 1. But in case of a square footing or a circular footing, the equation changes. So for a square footing, the equation becomes 1.3 times of C and C plus the second term remains the same, gamma df nq. The last term changes, it becomes 0.4 times of b gamma n gamma. For the case of a circular footing, it is given as 1.3 times C and C plus gamma df nq plus 0.3 times of the diameter gamma n gamma. So in our case, we have been given the ground level onto which the square and the circular footing have been placed. This is the square footing and this is the circular footing. The soil is sandy in nature. So as we saw in the previous slide, the ultimate bearing capacity for a square footing is given as 1.3 times of C and C plus gamma df nq plus 0.4 b gamma n gamma. And similarly, the ultimate bearing capacity for a circular footing is given as 1.3 C and C plus gamma df nq plus 0.3 times of diameter of the circular footing gamma n gamma. So here we can see that the depth of the footing is 0 for both, because both of the footings are resting on the ground level itself. They have not penetrated the ground. So df would be 0 for both the cases. Since the soil is sandy in nature and is cohesionless, so C will be 0. So the first term also becomes 0. So we will be only left with the third terms. So we need the ratio of the ultimate bearing capacity of the circular footing to the square footing. This will be given as 0.3 times of diameter gamma n gamma divided by 0.4 times of b gamma n gamma. So assuming the soil is same, so gamma would get cancelled out and n gamma is the bearing capacity factor which also gets cancelled out. We will be left with 3 by 4 into d by b. It is given in the question that the diameter of the circular footing is equal to the width of the square footing. So d by b is equal to 1. So this would turn out to be 3 by 4, which is the ratio of ultimate bearing capacity of the circular footing to that of the square footing. So the ratio of the ultimate bearing capacity of the circular footing to the square footing was found out as 3 by 4, which is option C. The relevant NPTEL reference has been mentioned.